Hey guys, welcome back to our channel Get This Sorted. In this video, we're going to solve a problem on shortest job first scheduling algorithm in the preemptive method. In the previous video, we have discussed the same scheduling algorithm, same problem, but in non-preemptive. Also telling you that STF in preemptive method is also known as SRTF, that is shortest remaining time first. So in the previous video, we have discussed non-preemptive example. So if you would like to practice it, make sure you take this example problem. We have 6 process here. I gave you the arrival time and the burst time. Calculate the average waiting time and average turnaround time by applying shortest job first for this problem. And comment below the answer. So this is the homework for you guys. Make sure you do it. Moving ahead, let's start with today's video. Today's video is preemptive mode of shortest job first, that is shortest remaining time for scheduling algorithm. Now, in the example that we are going to discuss here, we have 4 processes P1, P2, P3 and P4. We have their arrival time and burst time. So, we are supposed to calculate their waiting time and turnaround time. Let's get started. For whatever the problem it is, we start with the arrival time. We start at 0. At 0 point, we have only one process that is arriving into the queue, that is P1. And the burst time of P1 is 20. So, till 0 to 20, P1 will be executed. Now, if you can see, before the time 20, we have P2 arriving at 15. But the burst time is 25, which is more. In shortest job first, we will choose the job which is having less burst time. That's why we won't take P2. That's why P1 will be completing its execution. Moving ahead, now in the ready queue, we have P2. P2 arrived at 15 and the burst time for P2 is 25. Now, we can start executing P2 because P3 and P4 has not arrived yet. But what if we start executing P2? Then what happens is 20 plus 25 is equals to 45. Here 20 plus 25 burst time is equals to 45. Before 45, P3 and P4 will be coming. And the burst time for P3 is 10, P4 is 15, which both of them are less than 25. Therefore, P2 will be executing until P3 arrives because P3 is having less burst time. So, P3 is arriving at 30. So, 20 to 30, that is only for 10 units of time, P2 will be executing. So, 15 units of P2 is still remaining and still waiting in the ready queue. And P3 is arrived at point 30. So, we will execute P3. P3 will be executed for the burst time of 10 units. 30 plus 10 is equals to 40 and P3 will be completed. So we are left with 15 units of P2 and P4 is not yet completed. Now the unit is 40 and P4 will be arriving at 45. So by this time we can complete P2. So 40 plus 15 units of P2 is equals to 55. During 55, we have same burst time P4 with the arrival time 45 coming. But by the time P4 arrives, half of P2 will be done, right? So P2 will be continuing. When two processes are having the same burst time, we use first come first serve. Also, so 40 plus 15 is equals to 55. We'll complete the 15 units of P2 and we've cancelled. And P4 will be arriving into the ready queue at 45. At 55, P2 will be completed. So 55 plus 15 units of P4 is equals to 70. Till 70, this is how we draw the Gantt chart. So I hope you understood how we do the Gantt chart. If you have any doubts, make sure you comment below. Now let's note all the exit times for this process. So the exit time for P1 is 20 and P2 is 55, P3 is 40, P4 is 70. Once we note down all the exit times, we can calculate the turnaround time. Turnaround time is equals to completion time minus arrival time. So it is 20 minus 0, 20, 55 minus 15, 40, 40 minus 30, 10, 70 minus 45, 25. Once we calculate the turnaround time, to calculate average turnaround time, sum of all the values by total number of processes. So that gives 23.75. Similarly, to calculate waiting time, we have to do turnaround time minus burst time. 20 minus 20 is 0, 40 minus 25 50, 10 minus 10 0, 25 minus 15 10. So once we calculated all the waiting time, we can calculate the average waiting time by sum of values by total number of processes. That gives 6.2. So this is how we solve preemptive mode of shortest job first, also known as shortest remaining time first scheduling algorithm. So if you have any doubts, make sure you comment below. I hope the concept is clear. If you like this video, make sure you like it, share it, and subscribe to our friends. Thank you so much for watching till the end. Bye bye.